This one is tricky and requires a variety of different HTTP requests. Let's check out how to tackle it. I'll show you how I solve this problem in the addDevice.py script. I'm still importing requests and our getToken function, but also including the time library. You'll see why shortly. Let's jump into the main function. These lines are identical to the previous challenge. We grab the token, then form our API base path and headers dictionary. As a quick side note, if Cisco ever makes the always-on sandbox a read-only resource, you can always reserve a sandbox with full administrative access to test this out. In order to add a new device, we build a dictionary that contains the information required by DNA Center. How did I get this information? You could get it from the product API docs, however, we've already done that, so let's check out the OnBox DNA Center documentation for variety. First, I'll log in using the same credentials we've been using for our HTTP basic auth. Once logged in, I'll navigate to Platform first. Next, we go to the Developer Toolkit. From here, we can search for whatever operation we need, so I'll just scroll until I see an HTTP post request to add a new device. Okay, I found it. Let's dig in. Just like the DevNet docs, we see the URL at the top, followed by more details about required information. What makes this request different than other requests is that we need to supply an HTTP body. Here is a model of how our data should be structured. The model identifies which parameters are required and which are optional. In my example, I included all the required parameters and a few optional ones just to demonstrate how it works. For example, we have to specify an IP address and a CLI transport mechanism, which makes sense. However, other attributes relating to HTTP are optional. Let's check out the JSON schema. This shows us the required JSON structure of the HTTP body. This is a basic dictionary without too much hierarchy. The only gotcha is the IP address, which is a list of strings, so we'll need to account for this. Let's get back to the code. Hopefully this dictionary makes a bit more sense now. I'm following the schema that the documentation provided along with my device-specific values. Notice that the IP address key references a list of strings, not just a string. Now we can issue our HTTP post message to add this device. We use the same URL and headers as we did for the GET request as directed by the API docs, except now we specify an HTTP body using the JSON keyword argument. This will take our Python dictionary, convert it to the equivalent JSON syntax, and carry it in the HTTP post request. When we issue this HTTP post, we are not going to get a 200 status code back. This is an asynchronous operation, unlike the getDevices request we tested previously. Instead, DNA Center will tell us, okay, I'm processing your request, and if you want to poll me for status, you can use this task ID in an HTTP GET request to collect additional info. HTTP status code 202 is used to signal a successful asynchronous API response. Assuming the initial post succeeded, let's wait 10 seconds for DNA Center to process the request. Then we'll issue another GET request using the task ID pulled out of the response from the previous HTTP post. I'm showing that JSON response in orange so you can see how I came up with the corresponding Python code. Remember my movie theater analogy? This task ID is like our taco order receipt. Once I have the task ID, I can issue a GET request to a specific URL for async tasks. I just need to tack on the task ID to the end of it. I'm asking DNA Center, you gave me this task ID, is it done yet? A more professional application might do this in a loop, but in my case, I'm expecting it to be done after 10 seconds. As another alternative, perhaps the server could tell the client when it's done using the observer pattern notify or a webhook design, but we aren't using those advanced techniques here. The response from this request is shown in orange, again so you can understand how I am accessing data. The two most important keys are progress and isError. The former will contain any human-readable information, often error messages, and is sometimes blank when the operations succeed. The is error key should be false, which indicates the operation succeeded. I print appropriate status messages based on this value. There are many if-else statements here at various levels just to account for the possible points of failure. Let's run the code and see what happens. Okay, first we see that the HTTP post was accepted using status code 202. Then, after a 10-second wait, we see that the device was successfully added. There were many opportunities for failure, such as the HTTP post failing, the HTTP GET to check on the task failing, and the task containing some kind of internal error as to why the addition failed. Fortunately, none of those failures occurred. We could check the DNA Center UI to ensure our device was added, but that's no fun. Instead, let's use our get devices script we wrote in the previous challenge. We should see an additional device now with IP address 192.0.2.1, a device we did not see in the previous demo. Okay, there's our new device with the proper IP address and a new unique ID. At this point, you've seen examples of HTTP GET and POST operations, usage of access tokens, synchronous APIs, asynchronous APIs, and a handful of error checking techniques. As a side note, I've captured example JSON dumps from these various API requests into the JSON ref directory. Feel free to use these as references. Having these handy can enhance learning and simplify troubleshooting. Let's wrap up the course in the next clip.